All right, so this is the first coding. So this is the first coding step. We can already create a state machine here. There is a state machine concept and an editor. And this corresponds to the second commit here, the state machine concept editor and simple checking rule. So let me show you how this works, and then we're going to add stuff into the state machine. So the state machine is a language concept. It's defined in the state machine language. It is basically a concept that can be a root, so you can put it in the top, position of a model without, if it's not a root, you can only put stuff inside one of these. The root nodes can be the top level element in a model. Model are basically MPS files that store programs or models. So the state machine is that, and it implements one interface, the interface iname concept, which gives us a name property. And we could add this property manually here, but inheriting from this interface gives us a bunch of special MPS behavior. So you should always do that if you want to give something that has an identifier to a concept of yours. The editor for the state machine is basically a horizontal list, right, with two ingredients. One is the keyword state machine, and the other one then is the name property. And this is why the state machine lets us create, looks like this. We create another one, state machine, coffee dispenser, right? I'm going to enter the name here. Now, again, this is a projectional editor, so I can change the representation. I can call this machine of states. I can compile, Command F9, and then the existing objects, of course, change how they look, because again, a projectional editor creates objects with unique IDs, nodes, they're called in MPS, and then the rendering here is how they're represented. And if you change the rendering after the fact, then of course the existing nodes change. Now let's go ahead and put something into the state machine. For example, we can add the notion of states, the notion of events, and later the notion of variables. It's a good design idea to abstract the stuff that goes into something as a common interface, so you can exchange this later by just inheriting from that interface, because MPS uses polymorphism to decide what can go where. So I'm going to create this new interface. I call it I for interface, state machine content, content, right? And I'm going to create a new concept, the state, which inherits state machine content, state machine content. And then I'm of course going to take my state machine and add a child collection contents of type state machine content, and it can be 0 to many, so you can have many contents like this. And so structurally that's fine, but now of course my editor for the state machine needs to somewhere show these contents. So how do I do that? Well, I'm going to put the list of stuff right under the state machine. I use programmer language like syntax by entering a opening curly brace here, packaging this whole horizontal list into a vertical collection, and then closing these curly braces. Now basically, if I compile this, it looks like this, right? You can't put anything between that yet. I'm gonna delete the dispenser here. Can't put anything between those curlies because the definition here doesn't have anything there, but we can do that, right? So let's insert another thing, Shift Enter, and then put a horizontal collection here. And in the first element, we put the indent arrow, which just does an indent as you would expect. And then I'm going to embed the contents. Now the contents percent is the, if you will, shortcut for embedding a bunch of children, whereas what you've seen before, the curly, property name curly, is how you embed a place where you can edit a property of a node. So the contents, they are, because we've inserted this into a horizontal collection, by default, they are also rendered horizontally. If you look at the inspector for this collection here, you can see that it has a cell layout horizontal. And of course, we want to change this to vertical. It's outside. Let's see, vertical, right? So now we have this represented vertically. I'm compiling the language. And now it looks like this. And what can I do here? Well, I can press, for example, Control Space, and I can see that I can enter a state, which has no editor yet, so it just looks like this. It's rather ugly. So let's fix this. Let's go to the state and give it an editor. And how should that editor look like? Well, the word state, horizontal collection, the state's name. Oops, the state doesn't have a name yet. So let's go back to the structure and implement I named concept, right? Now we do have a name, and I'm going to use the same curly brace notation here just for the fun of it. Opening curly brace, right? Oops, sorry. And packaged into a vertical collection and closing curly brace. The transitions of the state go between this later. So we compile again. We go back to the traffic light. We can enter a state, red, and another one, state, green. Now there's a few things that are ugly. First of all, I want to be able to just type state, which doesn't quite work because we didn't define which text MPS should use to, if you will, let you type the creation of a node. By default, it takes the name of the concept, but that starts with a capital S. So let's define an alias. The alias is the thing you type in order to create an instance of the concept. And it's a good idea, at least for nodes or concepts that have a representation in text, to use the same thing here. This could be different, right? So let me just show you. I can now just type state and it creates one, right? I could make the thing you type different from the one you show. Let's just, for the fun of it, use the German word for state, Zustand, right? And now it looks like this, but I still have to type state, and then it looks like Zustand, which is not a very good language design, but technically it's possible, and sometimes it does make sense. Consider that you want to use an icon here, or a symbol, which you can't even type, like a sum symbol in math. Then it kind of makes sense. But let's go back to what makes more sense. In fact, instead of repeating the word here, we can just embed the alias, and then it's consistent by design. And now it looks like this, which is, I think, how we intended it to be. Now, to conclude this, if you will, step, let's see, it tells us we should have a checking rule here. And so let's look at this. Go here. The state machine already has a checking rule here that verifies that the name has to start with a capital letter. So if we change this to traffic light lowercase, then we get an error. Name must start with a capital letter. So how is that done? Well, there's a checking rule in the type system, you know, new checking rule, and it just, you know, checks if the name is not null, and then if it's not an uppercase character, then you use this error statement here with an error message that you assign with the respective node. This is basically Java code here. Of course, this is a Java extension that is used to annotate a string-based error message to a program node. In this case, it's the program node that represents the state machine which we're checking in the first place. Right. So in the same way as we have built the state, we probably should do something about events and transitions to conclude this story. So let's create the event. It also has a name, and I want to use it in state machines, right? And the editor for the event is simply the word event, packaged into a horizontal collection. Sorry, that was the wrong one. And then the name. Okay, compile the language. Go back to my traffic light, which now is valid again, and I can enter an event. I forgot to define the alias, so let's do that. You can see how language prototyping is almost as fast as you can think or speak about it if you have some routine in MPS. event another one, right? So that's fine. There's something ugly here. This red stuff is ugly, right? Because this is basically an instance of the abstract thing of the interface. So let's change this to give the abstract thing here, even though it's never really supposed to be instantiated. Let's give it an editor that is an empty line, and make it editable so we can start typing the other things. Now it looks like this, right? It's much nicer, but MPS still complains that an abstract concept is being used here. It kind of technically instantiated the abstract interface, which is kind of also ugly. So let's do this differently. Let's go back to the state machine content, to the editor here, and just delete this thing again, right? So instead what we're going to do is we're going to create the empty state machine content. It is a state machine content. It gives us the editor with the kind of empty editable. And now we basically tell the state machine interface here. It has, in fact, we need to cut this out. Now we go to the editor of our state machine and tell it that for these contents here, by default, the element factory, by default, we're going to create a new node of type empty state machine content. This is again just a Java expression that constructs an instance of that concept, which is kind of the empty thingy. And now when I go to my example and just press enter here, you can see that it creates this nice empty thing, and I can just type whatever I want. Now, of course, when I process the state machine somehow later, I have to take care of filtering out the empties because they don't make any sense. All right, so I think that's all for this video. Talk to you in the next video.